Hello and welcome back to Jeff Joff Masterclass. I'll be taking you through Pandas correlation quickly. In data science, we understand that the Pandas library provides a powerful tool for data manipulations and analysis. Pandas includes a function called corr. This is the function. Some people call it method. So it's a function called corr. So this function corr or method is used to allow you compute the correlations between variables in a data frame. So in statistics, correlation measures the quantities or the relationship between two variables, including how they are related to each other. So the corr function in Pandas can be applied to a data frame or a series in a simple way. And one thing that you should know that basically with correlation, you can either have this method which calculates relationship in the columns or in your data frame. So let's try it out and see if we can use. So that's the method that is used for correlation. So let's jump in. We're going to use a simple example that demonstrates correlation. So let's begin by importing Pandas. Import Pandas as PD, just to make sure it's within your cell and runs. And then let's create a data frame. So create a data frame. So let's see how we can create a data frame briefly. In this data frame, we can call it df, and then we can pass in a dictionary. We could say, let's say my var1 okay, let's put some values here like 5. Can do 1, 2, 3, 4, 5. You could separate this if you wish, and we can duplicate this. So this is going to be my var2 and my var3. My var is for variables. So we can change the values here in our list. Could do 5, 4, 3, 2, and 1, because we could also change the last value here. Okay, you could do that. You could do 6, 7, 8, 9, and 10. One thing that you should know, we just created a variable. Now we can go ahead and declare the variable df to be pd dot our data frame, and we pass into our df. Now we can compute the correlation. Let's compute correlation quickly. So these correlations can be in terms of correlation matrix. So let's just do correlation equals to, then it would be df dot corr with the corr function. Now we can print to see our results of our correlation in our terminal. Let's print the correlation. Just use the print function to display the output for correlation. So we don't have error in our or problems here, so we expect it to run in our terminal. Let's go ahead and run. Now this is what we see in the correlations. I want to explain briefly something here for you to understand. When you want to understand these results, how they are explained, you need to know that if it is a positive 1, it's a perfect correlation, or if it is a negative 1, it's a perfect correlation. The correlations can also be understood using the different methods. We have the Spearman's method, and we also have the Kendall, the Spearman's rank correlation coefficient, which can also make us understand this. But the corr function calculates the correlations using the default method, which is the Pearson correlation coefficient. But you can also specify other methods like the Kendall rank correlation coefficient. So that is what you could use to consider that. But just know that the correlation of 1 or negative 1 is a perfect positive correlation. Indicates the correlation of 1, and here we have 1 and 0.97. So this is a good correlation. The category of those correlations, I can try to show it to you here. So strong positive correlation is normally 1 or negative. That is what we call a strong positive correlation. So the value indicates a perfect correlation. As you can see here, this is a perfect correlation, this is a good correlation. A bad correlation only comes when the value is negative. That is what we refer as a bad correlation. And these correlations are also used, correlation matrices are also used to help you visualize your heat map using the Seaborn library. We will try to see how to visualize correlation using heat maps to get the visual representations of our variables, and we use the library Seaborn, which is inbuilt on top of Pandas to provide a convenient way for creating correlation heat maps. Let's jump onto that and we see if we can have that done, and that would be the quick understanding of correlation. We can now import Seaborn as SNS, then create a correlation heat map for you to understand. Okay, now to create a correlation heat map, you just write this simple code sn for seaborn.heat. Okay, then you do correlation and annotate to true, and then the color. So we can use the parameters to display, like using the CMap. So the annotate true will generate a heat map using the correlation or the correlation matrix, and then the parameter display correlation in each cell, we will use the CMap. So the CMap, which we can make it call warm. So this is a platter that will display the color on the correlation heat map. So hopefully we have everything written, and now we can try to show the correlation. Just display the heat map. Then to show the heat map, you just use plt dot show. Remember, we have not defined the plt. That means we need to import the other library for plt. So we can import matplotlib dot pyplot as plt, so that you do not get into error. So this code here will generate the heat map. Let's run it and see. So this is how you get the correlation heat map, and you can see clearly that when it's 1 is a positive correlation, perfect positive correlation. When it's also -1, it's a perfect positive correlation. But this 0.025 is a negative, but okay, it's a bad correlation. As long as it's less than 0.5, it's a bad correlation. So you can relate all this using the different methods. So these different methods that we can probably discuss them briefly and summarize the concept of correlation are the Spearman's rank correlation coefficient, which you could use the method just to demonstrate. You can use the method then which is a Spearman. We also have another way of specifying your correlation using, because the default is the Pearson's correlation coefficient. When you use the corr, which is the default, this corr for correlation, the default for pandas is Pearson's rank correlation coefficient. And we also have one last one, which I've just talked about it, which is the Kendall rank correlation coefficient. Kendall or Kennedy's. Kendall's rank correlation coefficient, which we use it with this method, Kendall. So these are the different types of correlations that you can use. But to make you understand is that when it's -1 or 1, it's a perfect correlation. It's a perfect correlation. 1 is a perfect positive correlation, or a perfect negative correlation if it is -1. Okay, and then we also have a good correlation if it is positive but above 0.5 and above, and bad good correlation if it is yeah, it's a good correlation if it is 0.5 and above, and it's not 1, and it's a bad correlation if it is below 0.5, whether negative or positive. So I hope you understand the concept of this correlation. Catch you on my next episode. See you. Subscribe.